Okay, there's a function that's going on where we want to work out what the integration is, and they're often doing it for functions inside of another function, a linear one. So we're talking about things like integral of sine. How can I get the integral of sine of some function t with respect to x? Now there's a standard one, if we haven't got this, that when we integrate, the integral of the sine goes to a minus cos. Remember our sine cos minus sine minus cos, differentiating is that way around, and we're reversing it, so the sine gives me a minus cos of 2x, and because when we differentiate we multiply by the 2, reversing it, we're going to get a half of the dx. Now the technique I'm going to show you allows us to do this quite a lot, and also with other functions, including a linear one, that this one's hidden. And what it relies on is by changing a variable, and we've got to be able to change all x's on this side into x's and u's. So the method we're going to use is something called by substitution, and what it says is we're going to integrate. We'll go with their first example, which is actually the integral of sine kx. In this case, they've got the sine of 3x with respect to x is equal to. And what we need to be able to do is say, I'm going to change this function into another function that's based upon it. I also need to change the dx. Now we can get dx by doing du dx. And this bit is actually about changing, what we're really doing is we're now changing a function sine 3x based upon an x function. We're changing this scale to turn it into a new scale based upon u. And that allows us then to redraw the same function and the same areas and the same everything from the curve by redefining it in terms of this u. So du dx is 3. So my dx can now be rewritten in terms of my dx is going to be replaced with some function in terms of du. So rearrange it, we get a du over 3. Okay, so now I can do an integral of sine of u with respect to du over 3. So it is now 1/3 the minus cos of u plus a constant, and put it back into terms of x. So minus 1/3 cos 3x plus c. And that's how you get this pattern to do with the standard integrals, where you take a coefficient of this number or the function inside and it becomes a denominator on the outside. We can do it with more general functions. So I did some example of an integral of cos 2x plus 3 with respect to x. We say u is 2x plus 3. We find out how to scale the axis. So du dx is still 2. Redefine dx now in terms of u. Set du over 2. And so this example number 2 becomes the integral of cos of u with respect to u over 2. Cos of u is going to give me, by integration, sine of u and a half of it. Put it back into the terms of my function, 1/2 sine of 2x plus 3. Let's see. And they don't talk about this one in there, but if you think about what's happening, the scaling part of this is what we need to change to scale my axis. The +3 actually just moves the x backwards and forwards. So all we're doing is resetting where the 0 is. Do a few more. Number 3. What's the integral of e to the 4x plus 1 with respect to x? And we now say u is my 4x plus 1 du dx. Therefore, it's going to be 4. So that leads me to dx equals 4, a quarter of du. So we've now got an integral of e to the u with respect to u over 4. So it's a quarter. E to the u integrates to e to the u by definition, and plus a constant. So it's 1/4 e to the 4x plus 1 plus the constant. A little bit more complicated. Let's bring some trig ones in. Bring in a trig function. So if I want to integrate sec squared 3x with respect to x. Now we recognise the sec squared. I'll just go and grab my standard differentials. So the sec squared, we know that it is a differential of tan x, so we're going to get a tan x result out of this one. Take my function u, which is going to be 3x, du dx becomes 3, which leads me to dx is equal to du over 3. So we now have the integral of sec squared u with respect to u over 3. From our standard definition here, sec squared we now know becomes tan. So it becomes tan u, 1/3 of that because of the 3 on the bottom, plus a constant which changes into 1/3 of tan of 3x plus c. And that allows me to get my integration in another form. Let's do a couple of fairly simple polynomial ones. If I do the integral of 1 over 3x plus 2 with respect to x. I don't like that thing on the bottom. This is actually one of the standard ones. They go on about with logs. And we do u equals 3x plus 2 du dx becomes 3, so dx is du over 3. So we're now trying to do an integral of 1 over u with respect to u over 3. Integrating 1 over u gives me a log plus a constant, which then turns into 1/3 the log of the modulus of the function plus some value c. Let's go to the last example I did in the lesson. So E4, that should be 5 and 6, sorry. So this was a question I think came actually out of the book. So we want to do e to the 3 minus x plus sine of 3 minus x plus cos of 3 minus x. Now for this pattern to work, these could actually all be different. And we could then do separate integrations. So we could do an integral of this function separate to the integral of this function, separate to the integral of this function. But because of the way they've done it, they're giving us a constant value to put in. So we've got u is 3 minus x, du dx is -1, which means that dx is equal to minus du. It's going to do a lot of sign changes for us. So we now get into our integral where we've got e of u plus sine of u plus cos of u, all with respect to minus du. So we get a change of sign happen. Hopefully with enough practice you don't need me to do the separate integration slide, so it comes out as being e to the u. Integrating sine gives me minus cos, so minus cos of u. Integrating cos gives me sine, so that's a plus sine of u, plus a constant. And we've got to multiply each of these by a negative sign. So it becomes negative plus, let's go back, I'll put these in a different colour. So the negative there changes all of these. Replace our values in our function, so we'll bring the cos u first. So cos of 3 minus x. Might as well keep the functions together, so minus sine 3 minus x, and then subtract e to the 3 minus x, and add some constant on. Okay, so that's using substitution. It's a very powerful technique, and we will be using it in further lessons where it will take some of the guesswork out for us.